Okay, so these are my video solutions to quiz 1. So the first question asks if a rocket is launched upward and the height of the rocket was 33.9 feet at the end of the thrust portion of the flight. The rocket landed 11.4 seconds later, and the rocket fell freely to the ground after reaching its maximum height. The acceleration of gravity is g, which is 32.2 feet per second squared. It's asking us to find the speed of the rocket at the end of the thrust flights. So we have these three kinematics equations: v equals v naught plus at, y equals y naught plus v naught at minus 1 half at squared, and then, or plus a, yeah, and then v squared equals v naught squared plus 2a delta x. So using equation 2, since we know that at the end, when it lands 11.4 seconds from the 33.9 feet, um, it goes back to 0. So we can use a second equation and find our v naught. So we plug in our knowns. 0 is equal to 33.9, which is our y naught, plus v naught times 11.4. It takes that much time from the 33.9 seconds to land back to 0. And then minus 1 half a t squared. Just doing some algebra, when we solve that, the initial velocity of the rocket at the end of the thrust flight is going to be 180.56 feet per second. Question 2 is asking a rocket is launched upward. The height of the rocket was 73.7 feet at the end of the thrust and had a velocity of 200.5 feet per second. The acceleration of gravity is given again as 32.2 feet per second squared, and it asks us to find the maximum height reached. So we know that the max height, the velocity is going to be 0. So we can use the equation v equals v naught plus at in order to find the time it takes from the 73.7 to reach the max height. So that's what I used here. I put 0, which is going to be the final velocity, is equal to the initial velocity, 200.5, which is a given, minus gt. And then you just solve for t, and you get t is equal to 6.22 seconds. So once you have the time, we can use the second equation, the y equals y naught plus v naught at t plus 1 half at squared, plug in our knowns, and then solve for our y max, which is going to be 697.9 feet.